All right. So if I want to do this in say 10,000 times, am I supposed to start and typing it out manually the way I've done? So in programming, we are programming because we want to make our life easier. We want to simplify things and automate it so that they run on their own. So now one way to go about it, I've not even finished typing the number of times I want. Let's say I want to print up to 10 times. You can see time is already passing and I'm not even done. And I'm hand coding. And what about in the future if the situation doesn't require me to doesn't require that I know what I am to print? So what we could do is to make use of any of these three types of looping systems. So we begin with the first one, which is the for loop. So I will write this. So this is the basic syntax for loop. This way, the way it is here. So in looping, it's more like perform this particular operation. After that, come back and start again. But this time, some inputs must have changed. Do it. After running it, come back and repeat the same task that you are given, but then with this kind of input. So basically, you're running the same block of code, but something has to be updating for it to run effectively. So the reason why something has to be updating, you'll see shortly. And the reason basically is so that it doesn't run forever. Because if you don't basically terminate at some point, the looping will run forever. So looping is more like cycles, going round and round and round and round and round, just like that repeatedly, but then with different kind of input. So this is a simple syntax for the for loop. So in this parenthesis now, this is where you specify conditions and variables which you want to operate with in your for loop. So for loop, I said, is just one of the different types of looping systems we have. If you look at the name, it says for. So to read it, it's more like saying for a particular condition, do this. Now, if taking this example I wrote down here, I want to print from number 1 to 10. What I can do is to type it manually the way I was trying to do it initially. Or an alternative is to do what? To create this syntax I've written here for loop. Then go inside here and tell it where to start from. For example, say I want to start from when I is number 1. So the first let me write the full thing so you understand it better. So for as long as I is less than or equal to 10, then I plus plus. So this is where I'll specify the condition that enables this for loop to run. So if you look, there are 3 partitions to these conditions. This is the first one, this is the second one, and then this is the third one. So for the first item here, which is the I equal to 1, this is where you initialize your basic variables. This is where you initialize your basic. I could have included more variables here, but what I need for now is just I, because that's just what I need to operate with. So for this first part, say I want my I to be what? Say I want my I to be 1. So I will just quickly type out what the first part, what it carries. Addition of variables. So that's what this first part carries. Then the second one, what does it carry? It carries the condition that must be satisfied before this looping system goes again. The second part, which is here, takes in the conditions that must be satisfied before the looping system goes again. So this third one is what happens after each loop is completed. So that's what happens in that's what you place in the third partition. This is I plus plus. Okay, I probably have not mentioned what I plus plus means. So this I plus plus is as good as saying I equal to I plus 1. So the other way I wrote it was a shorthand. I didn't realize I've not mentioned it before. So this is the same thing as what I wrote before, I plus plus. Just a shorthand for something that occurs frequently. So the third place, what happens after each loop. So that's what happens in this third place. So I said it that I plus plus is the same with I equal to I plus 1. So you'll be learning some shorthands in due time. So basically, taking our example, which says that which asks me to print numbers starting from 1 to 10. So what I would put here, any guess? Can anyone tell me what I would put here? Now this is what I want to write. Can anyone tell me what I will put here? The value of I. That's like 1. That's 1, right? Plus 1. Okay, so that's plus 1. This is what you're saying, right? Because the value of I is 1, which you have put here. Then you're saying plus 1. That's this one, right? Is this it? Okay. So this is the thing. Remember, this is what we're trying to print, this kind of thing. What about when it's 2, when the value is updated? What about when the value is updated to 3? So if I go and start hard coding I, and hard coding 1, if I print this thing now, you see what will happen. So I've printed this now. Can you see what's happening here? From here down. Can you all see? Ada, can you see? This part? Can you see it now? So you're seeing number 1, right? You're seeing it plenty times. Number 1, number 1, number 1. Can you see it? Yes, you can, right? Okay, and that's because I had coded 1 here. Here. I told it for each time we are in this loop, for as long as I is less than or equal to 10, you should perform this operation. Now you wouldn't want to start hard coding 1 here. What we want to do, remember, is to print from 1 to 10. So instead, what I'll do here is 1 and put I. So for the first time, when my I is 1, it will come here and print 1. So it has concluded with this loop now. So it will go back up. And remember, this one happens anytime. If you read it here, it says the third part is what happens after each loop. So after each loop, I want to tell I to increment by 1. So I equal to I plus 1 is more like saying the old value of I plus 1. So the old value of I, which was 1, should be what? Increased by 1, which becomes 2. So our new value of I is now 2. So this here you're seeing here is more like 2. So it will now come and check, is 2 less than or equal to 10? Yes, it is. Then perform this operation. Now it has completed. Then this third part will come and perform what is required to do, which is what? To increase by 1 again. So the old value of I, which was what? 2, will now be increased by 1. It becomes 3. So it will now come here and check again. Is 3 less than or equal to 10? Yes, 3 is less than 10. It will perform this operation. Now it will increase again. The old value of I, 3 plus 1, 4. Is 4 less than or equal to? So it will continue like this. Remember, notice that we are not going back to this one. It's only this one and this one we are now dealing with. So this one is just the first time when you want to enter the for loop. You guys understand? So this is just the first time before we enter the for loop. We initialize whatever I want to initialize here. So we initialized our I to be what? 1. This mustn't always be I. I could have called it J, just the way you name your variables. You initialize it to be 1. For as long as 1, for this one, for as long as 1 is less than or equal to 10, it will check for this one first. It will check whether it satisfies this condition. It will check whether it satisfies this condition. If it does satisfy it, will perform this operation. If I had come here and said I to be 11, it will check this. Did you notice that this thing turned to yellow? And that's because it will never enter this for loop. It's telling me that condition I less than or equal to 10 is always false, because I tell this thing to start with I being 11. Now, 11 is not less than 10. It's not even equal to 10. But if I made this to be 10, this loop will run only once, because 10 is equal to 10. So it's satisfying this second condition. So what you're seeing here is I could have just the basic mathematics sign. This is less than or equal to, you know, from your basic mathematics. Then you also have greater than or equal to. This is where it is written. The one you normally see is 2 equal to. This one is for comparing two things. So this one is for comparing these two things, if they are equal. So when you want to combine it with greater than or equal to, this is where you write it. This is for greater than or equal to. This is for less than or equal to. So since I've written this one like this, I started my I to be what? To be 10. This loop is going to run only once, because 10 is equal to 10. Now after running, our loop will then come and increase by 1, making it what? The old value of, that's like saying the old value of I, which was 10 plus 1, 11. And so now come and check. It will not go back here. This one is just for the initial times. It will not go back here. So it will now come and check, is 11 less than or equal to 10? No. So it will terminate. It will not perform this block of code again. Does it make sense to everyone? Any questions? No question. So if we wanted to print our numbers from 1 to 10, we initialize the first one to be what? 1. It will print number. This I will be 1 for that first time. Then it will increase to 2. Is 2 less than 10? Yes, it's still less than 10. It will print I, which would be 2. It will increase again to what? 3. Is 3 less than or equal to 10? Yes, it's less than 10. It will print value of 3. Then it will increase again. It will continue like this up until 10 is equal to 10. It will print 10. And then it will increase one more time. Then it will check, is 11 equal to less than or equal to 10? No, it's not. So it will terminate. So it will now go down and continue with other codes that are written under it. So this thing performs several times up until it finishes its operation. Then the code below it continues running. Any questions? Is it clear to us? Ada, Bukola, Jennifer, Chidimma, Amarachi. Your mic is not. I can't hear you clearly. I can't hear you clearly. It's breaking. Yeah, speak now. I can hear you. I can hear you now. Speak. Yes. Exactly. There's something like that. Now that means you should decrement the old value by 1. There's something like that. So I minus minus will be the same thing as saying I equal to old value of I minus 1. So there's something like I minus minus. Exactly. Now you have to be careful the way you do your things. If I put I minus minus, you know what would happen? Can you guess? Can you guess what would happen? You off mic. 0. Okay, so for the first, okay, yeah, it will. Okay, it won't be everything that will be 0, but one of them will be 0. So the thing is, the first time it's going to print 1, right? Because 1 is less than 10, right? Now for the second time, what would I be? Because we've said minus minus, it will be what? 0, and 0 is still less than 10. Now the third time, what will it be? 0 minus 1, that's minus 1, and it's less than 10. Did you notice a trend here? Anyone notice any trend? Remember, we started from 1. Is 1 less than 10? Yes, it is less than 10. It will print. Now you go to 0. Of course, you said minus minus. Is 0 less than 10? Yes, it is. It will print. Now you do minus 1 again, Abby. It will go to minus 1. Is minus 1 less than 10? Yes, it is. It will print again. Now you do minus 1 again. It will be minus 2. Is it less than 10? Yes, it will print. Can you not notice any trend? No one is noticing anything. So we started from 1 to 0 to minus 1 to minus 2 to minus 3 to minus 4. Are you guys not noticing anything? Look closer. What's wrong with this number?
Okay, all things. It's been a while.
Yeah, that's one thing. But they're all less than 10. They are all less than 10. It then means that this loop will run forever until our system or memory crashes. You get the idea?
I feel I want to add something.
You don't get it? Remember when we were trying to print from 1 to 10? We printed number 1 and increased to 2. Printed number 2. Increased to 3. Printed number 3. This is because we want to print from 1 to 10 bar. Now the person that asked if we tried I minus minus, what are we trying to achieve with this? So the thing wrong with that is this thing. Every number that is coming after 1, which is 0 minus 1 minus 2, they are all consistently less than 10. And this loop is going to run forever. If I click this thing now, you see the complaint you give me. Stack overflow error. You see the numbers is going to print. See, it's still printing bar. Are you seeing it? Are you guys seeing the terminal? I say you're getting it now. It's just printing forever and ever, because we told it to be going to the negative sign. Just continue going to the negative sign. Why would you want to print number if you're not making it of the values? See, it's still printing. It's just still printing. It will continue like this until you run out of memory. Your computer runs out of memory. And there is no occasion where you want to do this kind of thing. See, it's just still printing. Time is going. This is because you told it to be minusing 1. You told it to be minusing 1. So it's important to always look out for here the conditions you place. At some point, my computer will run out of memory. I need to complain. Or the other thing I can do is to stop it. You're getting the idea now. So the thing I wanted you guys to figure out was that this thing was consistently going to the negative sign, to the negative side. And there's no condition to terminate it. So the terminating condition is always this middle one. This one, I wrote it as condition. This is always the one that will make this thing to terminate. I told it to terminate whenever I is less than or equal to 10. That's more like saying when if I put only equal to here, it will not capture all those values that are less than 10. I mean, if I put it like this, if I put it like this, it will not capture all those values that are less than 10. That's 10 that I'm printing from 1 to 10. It won't capture 1, 2, 3. It will only capture for when I is equal to 10. So this thing is still printing, just still printing. And this is like 15 million. This is negative 15 million. I just keep going. So for someone that has lesser memory, computer memory, this thing would have stopped. So I have to stop this myself. It's not making sense. Is it clear to all of us? Share the way I put it here, ba? Exactly. Now, what did it tell our I to be in the first place? We told it to be what? You assigned it to be convo. Exactly. Now, is 1 equal to 10? Are you there? No, 1 is not equal to 10, but 1 is less than 10. 1 is not equal to... Yeah? Sorry? To do what? Huh? Yes, it can. It will not enter this loop to start with because 1 is not equal to 10. Now, if you want to execute this thing at all to 10, what about those other ones from 1 to 9? So this less than part is capturing from 1 to 9 basically. Because 1 is less than 10, 2 is less than 10, 3 less than 10, 4, 5, 6, 7, 8, 9, they're all less than 10. Now 10 is captured by this one. So when I becomes 10, it will check is 10 less than 10. Yes, it will now run this thing one more time. You always advise to be flexible. For example, I give you assignment now, I know some at all. I'll just remove this equal to. Any guess of what we printed? Anybody? That's what it will do. But if I put equal to, when it reach, because, okay, the way it is now, if I eventually reaches 10, it will compare. Is 10 less than 10? No. Instead, 10 is equal to 10. So because 10 is not less than 10, this thing will not satisfy. It will simply terminate at that point. Now, because I want to print from 1 to 9, I don't need to put that equal to part. I'll just put it the way it is. So it will capture from 1 to 9. So basically that's it. So I could also go the other way around. Say I want to print from, so at that, so if you wanted to go the other way around, wanted to print from 10 to 1, we want to use your system now of minus minus. So we could do minus minus. But this is your condition. You now have to be careful. You want to do it for as long as I is greater than or equal to what? Can anyone tell me what I want to put here now? I want to print from 10 to, basically I want to reverse what you did earlier. What will be the condition that we placed here? So this I'll change it to 1. So it will now make sense. So for the first condition, I is what? 10. Is 10 greater than 1? Is 10 greater than or equal to 1? Yes, 10 greater than or equal to 1. It will what? After that, it will come back and it will reduce our I by 1 as the I minus minus. It will now become what? 9. Is 9 greater than or equal to 1? Yes, it is. It will print 9. It will now what? Decrease again to 8. Is 8 greater than or equal to 1? Yes, it is. If you continue like this up until I becomes 1, it will check is I greater than 1. No, I is not greater than 1. What am I equal to? Is I equal to 1? Yes, I equal to 1. Then it will do this. But if I remove this equal to, it will terminate at 2 because 2 is greater than 1, yes, it will print 2. Then it will go to 1. Is 1 greater than 1? No. So it will not print. So put back our equal to. Does it make sense? So Ada, if you wanted to print from 10 to 1, this is how we place our conditions. Ada, do you understand? Okay, look at it more closely. So basically, this is what looping is like. Bukola, is she here? Bukola? Have fun, man. What's up now? I'm sure you understood everything. Have you? Any question for me? It's making sense now. Okay. Chidema, you just enter the commode. What's up? Has she left again? Alright. I think you have to work on that network. This is not like the first time. Okay, so so this basically is it for the for loop. So be careful about the conditions you put here, otherwise your system will run out of. It will just run infinitely. So it's just going to run forever and ever. So this is just one way of doing our looping system. Now there are other ways I specified before. One of them is what? While loop. Now while loop is a bit different from for loop, but they do the same thing. Now you use while loop when you don't know how many times you want to perform an operation. If you look here, I perform the operation for as long as, for this one now, for as long as I is greater than or equal to 1. That's what when I perform my operation. But there are times where you don't know when you don't know when you want to terminate something. When you don't know when you want to terminate something, that's usually the time when you use your while loop or to do while loop. So the basic syntax for while loop is just this. Then inside here, you write down the condition. So the while loop doesn't take up to 3 partitions like this one did. So for this one, this is 1, this is 2, and this is 3. Always be intentional about noting the syntax I put. If you look, what I put here was semicolon and not comma. What I put here was semicolon, not comma. And here, I didn't put anything. So I want to always tell you to watch out for the syntax. This one, by default, you should be learning it on your own. So after the first one, you terminate it with semicolon. So this is a statement of its own. This is a statement of its own. This one is a statement but continuous. So you didn't end it here because it's basically it's updates. You saw the way it was updating. So the semicolon is, should we say that the system puts it whenever the value of I is terminated. So basically you don't put semicolon at the end of this third one. So in a while loop, one difference is that what difference we can do is that we say, for example, want to print from 1 to 10 like we did the other time. What while loop just takes is the condition. It takes the condition and nothing more. Now you could have asked why I didn't specify where to initialize my variables from. Now in while loop, you do the initialization. Let me use J this time. You do the initialization outside. You do your initialization outside the way I've specified here. Unlike this one that you do everything inside this opening parenthesis. So for while loop, you do it outside. You specify this here. Then do it for as long as the value of J is less than or equal to 10. So to print with the while loop, what we could do is to what? It's to just print number J. So this is a simple while loop. Now if I print this thing, Can anyone tell me what would happen in my console? Any ideas? Any ideas? Exactly. All the numbers will be less than 10. But there's a reason why they are all less than 10. Can you suggest why? Or any person? Can anyone suggest? Yes, that's true. Yes, but what's 10, 9, 8? In the first place, there will be no 9. The second place, there will be no 8. In fact, there will be no other value. So what can we do to make it possible to get other values? Anytime you see the highlight like this, uh, yellow, it means that it's giving you a suggestion that something is wrong. But I don't want to highlight, I don't want to hover over it, so we'll see the suggestion. Can one of you give me why this thing is complaining? That's this part. That's this part. Exactly. This third one, right? This third one. That's exact. That's exactly what you need. But I mentioned earlier that what enters this bracket is only the condition. That's more like the second part. So what your answer is very correct. So what we need is the value that needs to be updating. If you look here, we're telling it for as long as I is less than. Okay, I've changed this. Okay, for as long as I is greater than or equal to 1. Now our I is 1, our J is here. Our J is 1 now. Now it will print this one. But the J is not updating the way I made our I to be updating here. So what we can do is to what? After you printed J, go and increase the value of J by what? 1. So it will be updating. Now this thing will disappear. Did you see it disappear? If I hovered over it, let me remove it, then hover over it, you see what the suggestion would be. It's telling us that the condition J is less than or equal to 10 is always true. And that value of J is what? 1. 1 is always, always, always less than 10. So this while loop will continue to be coming back. It will continue to be coming back. And 1 and J is simply 1, which is always, always less than 10. So it's not updating. So once it's after performing your operation, update that old value, which was 1 to what? 2. After 2 to 3 to 4 to 5 to 6 to 7 up until 10. It will now compare, is 10 less than 10? No. What about equal to? Yes, it's equal to 10. It will perform. Then increase what? To 11. Is 11 less than or equal to 10? No. It will terminate at point 11. Does this make sense? This one?
Yes, I saw something about the complete date under verification, but I don't know whether one of the just verify.
You mean for this one, right? Exit. That's what I'm telling you. That's just what it is. So this is the convention. This is syntax for writing your for loop. If you don't follow this syntax, that's like having 3 partitions. It would not work. The while loop takes only the condition. This first part is created outside. This last part is created inside the code block. But this middle one is the condition you place inside here. For as long as, that's basically, this one is English language. While what is happening? While J is less than 10, I want you to perform the operation that is inside this block of code. So yes, you're correct that it doesn't take the conditional statement. Sorry, the increment, the updating statement. So basically, this is updating statement. The updating statement for while is inside and not elsewhere. Do you understand now, Bukola? Yes. Otherwise, I could have written J++. They are all the same thing. The way I wrote I minus minus. Yeah. Here. Yeah. Yeah. That's just the way it is. You could have written it the way it was before. This is still valid. You get. Someone wants to ask question. Yeah, you can talk.
Okay, I will find out some print stuff around if I can see it. Then I'll proceed.
It's
Thank
very
you.
possible. It's very possible. It will work very well. It will work here. Yeah. The important thing, basically, what you're now saying is update the value before you even print. Remember, I told the code reads from top to bottom. I being what? 1. It will now come here and do what? 1 plus 1. It becomes 2. It will now print 2. It will come back. 2 plus, it will now come here. 2 plus 1, 3. It will print 3. It will continue like that up until 10. But what will then happen is that you will not print 1 because you put this statement first. So what I'm saying is that the statement, remember our I was what? Our J was what? 1. Now you're telling me that even before you print, increase yourself by 1. So it will now print 2. Sure, it makes sense. It will skip 1 because you put this statement before it. Then it will now come again. The J would have been what? 2. Increase yourself by 1. J plus 1 becomes what? 3. It will print 3. It's come back. 3 is less than 10. 3 plus 1, 4. It will print 4. So it will skip 1. You can see that. You can see it in the console. Let me run it. Does someone have a question? If you have a question, just ask. Stop raising your hand. Yes, when you're not sure of when to terminate, this is a simple demo now. There are occasions where you don't know when to terminate, but this one we are terminating at for I less than or equal to 10. So there are occasions where you will not know when you will not know where to terminate. So this one is a very simple example for which we know when to terminate. So I can't quite think of any occasions where we don't know when to terminate. So the person that asked the previous question, I think, answered him. If you look, it's also included 11 this time around. Yeah, it's so much, but yeah, yeah, I'm coming. I'll answer you shortly. So for this last one that we'll put this one on top, I'll put our updating statement up on top before this one. Observe that it printed 11. That's because we put it on top. So when this thing was 10, it incremented by what? 1. It became 11. It's printed. It printed 11. It's only then when it now comes here and check is 11 less than or equal to 10 that it will terminate. Meanwhile, we've done the increment first. So basically, when it was on 9, let's say when it was on 9, it came here, it's incremented by 1 and printed 10. Then to check, is 10 less than 10? No. Is it equal to 10? Yes. It will come here and do what? Update first. And then becomes what? 11. And then prints 11. It then comes after it has printed 11 and uncheck, is 11 less than 10? Yeah, no. So it's only that time it's terminated. So in most cases, your updating statement is going to be at the bottom. And if you observe, it didn't print 1. Let me do Control Z. If you observe that it didn't print 1, because we moved it from, we changed it from, we updated it first before even printing. So for this case now, what we could do if we want to, if we want to be stubborn and say I want to update first, what we could do is to change this to 0. What we could do is change this to 0 and change this to remove this equal to. So what would happen now is 0 will come in first. Is 0 less than 10? Yes. So 0 plus 1, 1. It will print 1. It will print 1. It will come again. Is 1 less than 10? Yes.
Yeah. That's the get something. So then talking about
Can you see it? Can you see it? Is it clear?
Business center wà láàárín leadership ní empower also
Can you see this part? This part? This part? The part I highlighted now, can you see it? Can anyone see it? Huh? No, this. No, does this. Can you see? Can you see the highlighting I'm doing now? This highlighting part. Huh? Okay. Okay. Very fine. Okay. Very fine. So so I started from 0, and now what? Check if it was less than 10. Yes, it is. I increased by 1. Then it will print 1. Then you continue like that. It would go again. Because we increased first, it will check if 1 is less than 10. Yes, it is. Increased by 1 to print 2. It continues like that up till 9. Is 9 less than 10? Yes, it is. It would come here, increase by 1, and then print 10 to the console. Now, eventually, when it comes for 11 and check if 11 is less than 10, of course, it's not less than 10. That's when the statement will terminate. So by changing our statement like this, remember we did it like this because we wanted this updating part to be on top first before the printing statement. So if we did it like this, we've gotten our values back. So it has printed from 1 to 10. Does this make sense to all of us? All right. Bukola, before we print the 1 million you asked of, does this one make sense? All right. All right. All right. So if you wanted to print from say 1 to 1 million, from 1 to 1 million, just specify your distance here. For as long as this is equal to less than or equal to, so this is 1 million. For as long as this is 1, 2, 3, 1, 2, 3. For as long as 1 and j is less than or equal to. So I want this to be down here. I don't want it up the way it was. So for as long as j with the starting point 1 is less than or equal to 1 million. So it would actually print from 1 to 1 million. You saw before that we printed as far as 15 million. Exactly, that's what I'm saying. I'm telling you. So this is not a typical situation. This is not a typical situation. You've not started solving top algorithms. That's when you will most likely be using while loops because you don't know when it will terminate. But for this example, we know. For this example, we know. So, so what you're seeing now is number 1 to 1 million. So this is it. You can see my scrolling is not ending anytime soon. All right. So, any questions? Any questions so far? Yeah, go ahead. The question. Okay, when I'll give you assignment after now. You see what the question looks like. And who is it? You may explain it if you don't understand. Yes, yes, yes. Okay, there are okay, okay. For example, if I could give you I could give you an array. Okay, you're not introduced yet into an array. You don't know what array is. I could give you an array of numbers. Okay, let me not make it of array now. I could ask you to sum up all the numbers from one to 10. Do you get? I could ask you to sum up all the numbers from 1 to 10. How are you going to do it? How are you going to do it? Are you going to start doing 1 plus 2 plus 3 plus 4, just like that? So a simple solution is to use loops. Do you know how to go about that, or should we do it? Sorry? No. Sum up all numbers from 1 to 10. All right. Let's do that. Let's do that before we do the do while loop. Or let's just do it with the do while loop. So for while loop, any questions? No questions on 1, no questions on 4. Right? All right. So the third looping system we have is do while loop. So this is the syntax. So you do something, you do something. So you do something for as long as this condition is satisfied. So using our common example of ranging from 1 to 10, what you could do is to what? Uh, number I. So it just operates. Sorry, forget about. Is it the same for every other person? It could be your own network, or is it the same for every other person?
Hello, I understand.
Can you, okay, you guys can see it, right? Okay, so it's possibly the network from their own end. So
Then you proceed to another
just
step.
like the while loop, the do while loop, this thing is instantiated outside. You instantiate it outside just this way, and the conditions are specified in the while loop is written outside. It's written outside this opening bracket and closing bracket. So for as long as what k is less than or equal to 10. Can you guys see the screen? And is it clear? Any questions? Are you all here? Jennifer? Chidima? Can you see what I'm saying? Ada? Abigail? Bukola? It's network. It's network. Okay, I'm coming to that. I'm coming to that. Is your network good? Can you follow up the way I'm demonstrating? That means it's from Jennifer and Bukola. It's from your own end. If some other person can see it's clear, then it's from your own end. Okay. Amarachi, can you suggest what is missing here? Your network is clear. Is she there? Okay, okay. Do while loop. But can you see the screen now? You, can you see it? Okay, okay. Yes, yes, yes. You can see it. Amarachi, any update? Was she the one? Okay. So, so just like the while loop, you need to update the value. So you need to update the value. So it knows what to check for in this condition. Does it make sense? So you need to update the value so it knows what to check for. Otherwise, if you leave it at 1 is always less than 10. So this is going to continue running forever. So update it from 1 to 2 to 3 up until 10. So it knows when to terminate. So this is 1 to 10 printed. Alright, so let's sum up all the numbers from 1 to 10. So what we could do is to what? Initialize our sum statement and assign 0 to it. So what's and then we put our first the variable to carry the first number that we want, that is part of the numbers to be summed. So let's say that our k is equal to 1. Now what we do is to what? Sum it this way. Sum is equal to sum plus the value of k. And then update the value of k to be equal to k plus 1. Then after everything, we can print out our k, our sum rather. So this here is our sum. Initially, it will be 0. And then we initialize the value of k to be what? Remember, this is the number. This is the number we want to add up together. We want to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this number we need to add. So whenever you want to do your something, it's always good to initialize it to 0. Because 0 is basically non-entity, it means nothing. So you initialize it to what? Carry 0 first. So it will enter this loop and do what? Sum, which is the old value of sum, which was what? 0. To do what? You add, what are you adding to it? You're adding the value of k, which is what? 1. So after everything, our sum would be what? 1. So our sum would become 1. And then it will what? Increase the old value of k to what? 2. So it will now come and check it's 2 less than 10. Yes, it is less than 10. Then it will now come back here and do what? Our sum, the old value of sum, which is what? 1 plus what? The new value of k, which is what? Which is what? 2. So our sum here will become what? 3. So when it's done with this one, k increased by what? By 1. And our k becomes what? 3. And then our old value of sum, which was what? 3. Plus value of k, which was what? 6. 3. Our sum then becomes what? 6. So following this flow, it sums up all the numbers from 1 up until the value of k is less than or equal to 10. So it will sum up until k is equal to 10 and add everything. And remember what I told you, this loop continues for this condition for as long as it is satisfied. Once it finishes, every other thing outside of it will run. Now, if you sum from 1 to 10 now, you're expecting it to be 55. So this is one example we can solve using the looping system. Now I did this with the do while loop. Ada, are you there? Does this make sense? And every other person, does it make sense? No, I don't quite understand. Initially, okay, these ones I wrote here. Okay. Ada, is that the question you're asking? If it's necessary to write these ones, or is it something else? No, it's not necessary to write this. Anytime I write this thing, just now I'm trying to give more, I'm throwing more light to what I'm saying. You don't need all these things in your code. In fact, when you're submitting your assignments, you can comment only when it's necessary. Don't be putting comments unnecessarily. So this is basically what is needed. Yeah, yeah. Okay. Which line? Yeah. All the numbers from 1 to 10. Exactly. Yes. Uh-huh. K plus 1. Okay. You mean something like, can you speak it? Let me type it. So let's see if it makes sense. Okay. Okay, sum is equal to K plus what? 1. Okay. I think I get what you're doing. I get what you're trying to say. And then after that, we increase the value of K, right? Is that it? Now this is the problem. This is the problem with this statement now. This is the problem with this statement. For the first time, our K will be what? 1, right? And then it will increase and becomes what? And becomes, okay, let's run it. Let's run it. So it then means what you could do is to initialize this to 0. What you're actually suggesting could be another solution, but would then initialize this to 0. But let's see what the output will be first. So it's 11. So it's 11. So basically, if you do, I don't know if you should. Have I introduced guys to debugging? How to debug? Okay, okay. I'm not doing that now. So what's happening is more like our starting value of k was what? 1 and 0. Let me comment this. 0. 0 plus 1. It will give it a value of sum. Now, what about the old value of sum? What about the old value of sum? Like when we did, like the way we did it here, sum plus k. What about the old values, the numbers you summed in the past? Say 1 plus 2, 2 plus 3. Are you now going to throw away those values? Because that's basically what's happening with this line of statement. You're not considering those old ones you added before. You're only considering the new value of k. And eventually, when it gets to 10, what's happening is 10 plus 1, 11. And that is what becomes our sum. That's why this thing is 11. It prints only that, only the last one. So this statement here is not, would not do the task we are asked to do. So this one here is what is required to solve it. Any other questions? So with this one, this is what's missing in the old one. This one keeps track of the old value of sum and takes in the new value of k and adds to it. So this is more like 1 plus 2. That will be the value that will be stored in our sum. Let me write this thing down. Sum. Our sum is what? Initially to be 3 from this 1 plus 2. 1 plus 2. Now I want to add 3. I need the old value of our sum, which was 3, and then add to it plus 3. It becomes what? 6. Now our sum is 6. Now I want to add 4. I need our old value of sum, which was what? 6, and then do what? Add 4 to it, which becomes what? 10. Now I want to add 5. We also need the old value of sum, which was what? 10. And add 5 to it. It becomes what? 15. We do the same for 6. It becomes what? 6 plus 15 becomes what? 21. Then plus 7 becomes 28. Plus 9, it becomes 35, I think. Then plus, I must have made mistake in my summation. Then plus 10. What if you do this correctly? 1 plus 2 plus 3 plus 4, it should give you 55. Guys, any other question? Yes, you can. Yes, it's just the same system. It's just the same system. So that's what looping is basically all about. You want to do something a number of times, and you don't want to start doing it one. You already have your looping system of, you know how to go about it. So this just makes your life easier. Makes your life easier, and well, that's just it. That's just it. Any questions? So the thing that was wrong with that other one, I think, was it Amarachi that suggested, was that the old value of sum was not considered when solving the thing. So what it did was just to consider the last value of k and added 1 to it, and then made sum to be that value, which was 11. All right, all right. So Ada, you're saying something earlier. You're saying something earlier which I didn't quite get. Could you come again about what the assignment on this would look like. What the assignment on this would look like. Yes. Yeah. Yeah. Yes. Yes. But you still end up solving it. You still end up solving it. Uh, three how many? Three what? Days. Uh-uh. Is it like that for every other person? Is it like that for every other person? All right. All right. But some of you end up doing it very well. Okay. Like some of you actually end up doing it very well. Yeah. Yeah. And you too, self. Your past couple of assignments, you did it correctly. So I don't know. I don't know. Yeah. No, that's from your own fault. I think every other person got to know about that. That's your own fault. Yeah, that's what I'm saying. That's what I'm saying. And this is a different scenario, and that's from your own side. Every other person got to know about it. They knew that assignment was dropped. I believe I announced it. I announced it, right? Yeah. Let's check. Let me check ourselves. Yeah. Yes. Yes. Mm.
Hey! What's he bring up?
Uh,
You not bring juice, so. Yeah.
so this is the thing. This is the thing, and that's actually why programming is thriving because there's community of developers who come together to stay in one group. They share resources and they share updates. So it's not up to me. If you see that it's something that can help you, you guys, you have your numbers now. You can collect the numbers from the WhatsApp. Create another group. Add yourself into the group. You don't need to add me. So you update yourselves. You update yourselves on what happened. It's not that one is not up to me, like you've said. Since you don't, it must the admin don't have to be in the group. So collect the numbers from the WhatsApp exactly. Just create it and add yourselves in. Okay, okay. No, no, you're not. Go ahead and do that if it will help you. You understand? If it will help your growth, go ahead and do that. No wahala. Yes, I saw that. What's the complaint it was telling you? Okay. Okay, you may want to try to be remembering errors or difficulties or blockers you meet along the way, because it will help you. There are repeated problems you come across. So if you have the solution already from the past, you don't have to start beating about or going on the internet to look for solution again, all over again. So okay, so I'll look at your this thing, but I couldn't see anything that could have caused you not to work. For that assignment, we are just required to create two methods. That's this like one method and then another method. So if you did it like that, it should work fine. But I don't know, Sha. You should try it. You should try to put all of them in one file. If the error comes up again, then you can tell me what's up. They'll know how to go about it. Yeah. So try to put them in one file, and then another thing. For now, I saw in one. I think it was Bukola. It's possible for you to have two classes in one Java file like this. But for now, you don't need it. Because I saw that you created two classes inside one file. It's possible, but you don't need it now. You didn't actually do it correctly. So you do your one class like this, and then inside it put every method you need. There's no need for you to start creating two classes. This is a class. This is a class, right? So create a class like this, and then every other method or function you'll be creating, just like this main method, should be inside or within the class. I saw that you created another class. This one that has public class, uh, hello world. This is a class of its own, and this class means that this class keyword means that you're creating a class, but you don't. You should just create another method. Let me create another method here now. You don't need a new class. Let me create another. For example, I call this another method. So this is all you need. Then put your code inside here. Put your code inside here. If you want another method, you can create it. For example, you can write a method that was sum or let's say some numbers. Put whatever you want to put. You can create as many methods as you like. You can create as many methods as you like. No need for you to start creating a class, another class. Is this clear? Any other any other question? Any other question? And one thing we were supposed to cover, which we didn't, was we're supposed to cover this in last class, was the switch statement. What we did in last class was the if else and else if statements. That's conditional statement basically. So what the last thing we're supposed to cover is the switch statement. So I'll give you a very simple example. You go and just go and look the thing up. If you have any question, you can drop it in the chat or in the next class we just treat it. But this switch statement is an alternative to the if else statement. It's an alternative to if else statement. So if for example we wanted to print a number, if we wanted to print a okay, we want to print only even numbers. So we are given an argument n. We should print it only if it's. If you're not hearing me, let me know. It's raining over here, so I'll just try to be audible enough. So we should print it only if it's an even number. So what we could do is to use the switch statement, which I said is an alternative to if else statement. So in in here we can pass in the parameter n. So what you could do is uh, you use case for the different options that we could have under the switch statement. Now, if what? If n modulo 2. Now, this is how to check if number is an even number. This is how to check if a number is an even number. Sorry. Okay. I'll just, all right. What you could do is to establish a boolean here. I'll call it b. And then n modulo 2 equals 0. All right. Now this is a case for when it is true. If when it is, I'll change this to b because we're working with boolean now. I'm not sure if this will make more sense to you guys. Okay, you know what? Let's go through this in the next class so I don't bore you guys. So through this the switch statement in next class. So for today, you've covered the for statement, the while statement, and the do while statements. I'll be terminating the class here. If you guys don't have any further questions, let's just end it. All right. So our next class, I guess, should be all day, including night. You know what? You know what? Let's talk this. Let's talk this privately. Yeah. All right, guys. We see when we see on Monday. If you've not if you've not submitted the assignment, if you've not submitted assignment, please do where to do that before 12 a.m. today, tomorrow.